Hi, welcome back. In this video, we're going to talk about how do we simplify a rational expression when we're adding and subtracting. Okay, in our previous video, we simplified through multiplication and division, and in this video, we're going to be doing adding and subtracting. So it's good to remember the basic rules of just adding and subtracting fractions, right? So let's say that we have 1/2 plus 1/4, right? In order for us to combine two fractions, we have to be able to have a common denominator, right? If you think back to when you started learning this, we had 1/2, and we had this as 1/4. We can't add both pieces and say we have two pieces because they're not the same size of pieces, right? We have to cut this one into the same number of pieces. If they both have 4 pieces, then we can say we have 1, 2, 3 out of 4 pieces, right? And to do that, you probably were taught that the least common denominator here would be 4 because 2 goes into 4. So you multiply this times 2, this times 2, which then turns this problem into 2 over 4 plus 1 over 4, right? 2 times 1 is 2. You get 4. And because you have a common denominator, you can combine these two fractions as 2 plus 1. And that's how we get 3/4, right? We want to find the least common denominator when we're adding and subtracting fractions. And we will do the same, but with rational expressions, like quadratics and, monomials and stuff. So let's get to it. Let's try a few examples. Here's our first scenario. We're adding these two fractions. Notice how these two fractions already have a common denominator. So to simplify this one, we already have a common denominator. All we have to do is combine the numerators, which is x plus 2. And that's our simplification, right? Just like over here, we were able to add 2 plus 1 to get 3. If we can simplify, we would, but in this case, we can't. Just like x plus 2 and x plus 3 can't be simplified further because these are grouped together and these are grouped together. It's just as simple as it gets, right? Our goal through this example is, can we find a common denominator for us to be able to combine the numerator? And I'll slowly increase the difficulty of these examples. So feel free to move along a little bit, scroll to the right, go through more complex ones, or just walk with me through the simple ones as we increase the difficulty together. So here I'm subtracting these two, but notice how these two fractions have a different denominator. So the least common denominator is my first goal. How do I find it? Well, in a previous example that I showed you, 2 went into 4. So we just multiply this by 2 times 2 to make both of them 4 as a denominator. But what do you do when they don't have something in common? Like, let's say we have 1/2 plus 1/3, right? How would you combine these if they have nothing in common? Right? So what you would do for the least common denominator is you would find the product of the two. 2 times 3 is the smallest number that they both fit into. And to get a 6, we needed to multiply this by 3, which turns it into 3/6. And we multiply this one times 2, which turns it into 2 over 6. Yeah? Then, once you have a common denominator, you can combine the numerator. 3 plus 2 is 5 over 6. So whenever they don't have something in common, or when one is not a multiple of the other, right, you multiply the denominators to find your least common denominator. I like to always go back to the scenarios that I remember, right? Whenever I forget some of the rules of math, I go back to the most basic form and I lean on that. So since they don't have anything in common, this one is x plus 2. This one is x minus 2. I'm going to multiply them together. So my least common denominator is x plus 2 times x minus 2. Okay? So I'm going to rewrite this fraction as x plus 2 times x minus 2. Now if I multiply the bottom here, I want to multiply as well the top. So 3 times x minus 2. The second fraction already has an x minus 2. I need to multiply this one times x plus 2. And I multiply the top times the same value. Notice how they both now share the same fraction. And by that I mean the denominator. With the same denominator, I can combine the numerators. I can just say the bottom is x plus 2 times x minus 2. And then on top, I have 3 times x minus 2 minus 1 times x plus 2. Once I can combine the two fractions into one, my goal is really just to simplify. So let's distribute. 3 times x is 3x. 3 times negative 2 is negative 6. Negative 1 times x is negative 1x. And negative 1 times 2 is negative 2. As I distribute, I can get rid of the parentheses, and I can still combine a few things, right? 3x minus 1x is 2x, and negative 6 minus 2 is negative 8. X plus 2 times x minus 2. Now, I'm always going to try to simplify the problem as much as possible, so I notice that the top has a 2 in common. They can be both divisible by 2. So I can rewrite this problem as 2 times x minus 4. Right? 2x divided by 2 is just x, and negative 8 divided by 2 is negative 4. In the denominator, I have x plus 2, x minus 2. Unfortunately here, none of the factors can cancel out. So I could have just left it like this. I wanted to factor it to see if it was, if I could reduce the fraction some more, but it doesn't. So you can write it like this, you can write it like this, you could even write it like this. I said that we have 2x minus 8, and in the bottom, if I wanted to multiply these, I would end up doing FOIL method, right? I'll do it here on the side so you can see x plus 2x minus 2 could be expressed as x squared minus 2x, positive 2x, and negative 4, which comes down to x squared minus 4. We have 3 different ways of expressing the same answer. At this point, it's going to be your choice, right? How do you want to simplify it? It can't be reduced further, so I leave it as this. Again, I'm going to increase the complexity to some of these problems. The goal is just practice and some exposure, right? So feel free to pause whenever you feel like you're getting the hang of it and you can do one by yourself. If you feel you can do it, give it a pause. Try it out, solve it with me, and then press play to see if we get the same answer. When I'm finding the least common denominator, I have to first make sure that the problem is in factored form. So when I see x squared minus 4 down here, I need to rewrite it in factored form. Now, x squared minus 4 can be expressed as x minus 2 times x plus 2. This is the difference between two squares. If you want to see it laid out, you can add a 0 in the middle, and you can do it the other method that we spoke about. This just turns into 2 times negative 2. Right? When you cross multiply, they'll add up. A 2x and a negative 2x will cancel with 0. That's how I got my x plus 2, x minus 2. So I'm going to rewrite this problem, but in factored form, right? If I see any quadratics, I want to factor them to make sure that I can see if they share anything in common. Right? All I did was rewrite this in factored form. And the other one is already in factored form, because there's nothing to factor. So, what will be my least common denominator? Notice how here, these two fractions, they both already share an x minus 2 in common. But this one is missing an x plus 2. So, my least common denominator for both fractions have to include both products. They both have to include what they already have in common, and then the additional one that this one is missing. They have to have the same number of common same number of factors in the denominator. So for the first one, since we already have x minus 2, x plus 2, I didn't have to multiply this times anything. I just copy this one as is. But the second fraction, I am missing something. I already have an x minus 2, right? I need to include an x plus 2 on top and on the bottom in order for them to have the same denominator. Now they have a common denominator, and I can combine both fractions into one. So now I have 2x minus 1 times x plus 2, all divided by x minus 2 times x plus 2. Right? The whole goal is to combine these two fractions into one. Right? So in order for us to subtract the numerators, I have to have a common denominator, which they do now. Once I have that, I can simplify. I'm going to distribute the negative 1. I have 2x minus x minus 2. I'm going to divide both by x minus 2, x plus 2. 2x minus 1x is just x minus 2. Notice how, in this scenario, they both share an x minus 2 in common. So these can actually divide, leaving me with just 1 over x plus 2. Okay. I was able to reduce all of this through this process to 1 over x plus 2. So we started by factoring this. Once we wrote it in factored form, we were able to realize that they already did share something in common. And we added the part that was missing for the second fraction. So we can combine them, and then as we combine like terms and simplify it, we're able to come down to just 1 over x plus 2. All right, how are we doing so far? Feel free to pause this one and give it a try. All right, we see a quadratic here. I want you to factor this in the bottom so you can see if any of these two denominators already share something in common. If they do share something in common, it'll help us with our LCD. So start by factoring this 3x squared plus 5x minus 2. As I factor it, I get 3x times x. And I get 2 times 1. Now I'm going to write it as 1 times 2, because when I cross multiply, this gives me 6x, and this gives me 1x. And in order for me to get 5, I need to do 6 minus 1, which means this minus 1 came from up here. So my factors here are 3x minus 1 and x positive 2. So as I rewrite this problem, right, as I rewrite the factors here, the factored form, I'm going to write it as 2x divided by 3x minus 1 times x plus 2 plus 1 over 3x minus 1. Notice how both of these fractions already do share something in common. So what's going to be my least common denominator? Remember, the least common denominator has to have the same number of factors on both denominators. They already share 3x minus 1 in common. So that's for sure. And then we need to add the x plus 2 as well. So both fractions have to include this. The first one already does, so I copy it as it is. There's no changes necessary. The second one, though, only has the 3x minus 1. I need to include the x plus 2 in here. So I multiply the top and the bottom by x plus 2. Now that I have a common denominator, I can combine the numerators. Yeah, I can distribute, simplify, combine like terms, all that stuff, right? So we got 2x plus 1x plus 2. all divided by 3x minus 1 times x plus 2. I can still combine like terms. I get 3x plus 2 all divided by 3x minus 1 and x plus 2. I'm not able to factor anything here in the top, and I'm not able to cancel anything. So I can leave it like this, or I can multiply this again. And if we remember, 3x minus 1 times x plus 2 came from up here. 3x squared plus 5x minus 2. So I can write it like this, or I can write it as 3x plus 2 divided by 3x squared plus 5x minus 2. Right, they're interchangeable. I can't simplify it further, and these are the only two ways of writing the solution. So, if you are still watching this video, don't forget to like and subscribe. Please let me know if you have any further questions, and as always, we'll calculate.